In this module I want to discuss the gas laws. Now these laws are very useful in solving many problems involving expansion of gases. So what are the gas laws? Well, the two main gas laws are Charles' gas law and Boyle's law. Charles' law says that this is the volume of a given mass of gas is directly proportional to the absolute temperature when the pressure remains constant, and this can be expressed as V1 divided by T1 equals V2 divided by T2. So that's Charles's gas law. Now Boyle's law is, this is the volume of a given mass of gas is inversely proportional to the pressure when the temperature remains constant, and this can be expressed as P1 V1 equals P2 V2. Now these two laws can be expressed as what we call the general gas laws, and this is P1 V1 divided by T1 is P2 V2 T2. And you see, you can interchange any of these and you can solve all the gas laws. Now it's important to note at this point that the temperature, the T in the gas laws, is in Kelvin. You must convert the temperature, the Kelvin scale, because we always use Celsius. Generally 0 degrees Celsius is minus 273 degrees Kelvin, but when you're using these formulas you've got to apply it in Kelvin. You've got to. Let's do a few examples to demonstrate how these laws apply. Now a cylinder charged to 250 bar has a volume of 30,000 millimeters cubed at 25 degrees C. It's involved in a fire and reaches a temperature of 350 degrees C. Its volume increases to 31,500 millimeters cubed. What would be the pressure inside the cylinder? Well, all you do is insert all these variables in the general gas law. However, before you do this, you've got to convert them all to what goes in the formula, and that main one is the temperature, to Kelvin. Therefore 25 degrees C is 298 degrees Kelvin. Don't forget we're covering a module. 273 degrees Kelvin is 0 degrees C, so you've got to add on 273 degrees. And 350 degrees C is 623 degrees Kelvin. You've got to do that before you put them in. Now if you put those in, as you can see here, and multiply it out, as you can see here, you get this at this point, 25,168 equals P2 times 31,500 divided by 623. If you transpose that again, you get this formula. Therefore, multiplying it out, you get P2 equals 498 bar. That's the answer, 498 bar.